I'm Pavithra. If you're new to my channel, I make videos about machine learning, career and goals, travel vlogs, and some lofi music for productivity. To people who have visited my channel before,
I know you know a lot of super people, so thanks for thanking of me.
hello everyone. In today's session, we'll see about what is machine learning and its types and why machine learning is evolved and what is the reason behind it and few examples around machine learning. So before starting with this topic, let's understand three things which is highly important in learning ML topics. The first thing will be it's all about data. So whatever you do without a data, it is impossible to start with ML and other models which is related to it, because
we cannot build a model without feeding the data, actual data, or
for example, we cannot just ask a model to identify an image, whether it is cat or dog, without saying what it is actually, without giving the feature in it. So we have to say a mission, what is cat and what all the features it has, and what is dog, what all the features it has. The second thing is it's all about learning. So you're just trying to make a mission to understand from scratch. So you have to start from the beginning, from the data, and it will learn by itself. So for learning, it has its own algorithms and some of techniques provided with certain tools. So these are the things which is actually available in ML which help to learn, but it cannot generate its own data. So we have to feed our own data or for the certain objectives that we are trying to build in with. So the third thing is data again. So it's a cycle. In a definition point of view, we are just trying to make a mission to understand or to learn by itself by feeding certain information. So this is the quick introduction about machine learning. So why machine learning? If you remember, there were like 20 years back, we had a huge problem behind data handling. Companies like Google, Amazon, or people who are actually directly facing customers towards them, they are facing so much of problem in handling those information, because they are spending so much money on storing and they are spending so much money on maintaining it, but they don't know what to make out of it. For example, they cannot delete those information. They cannot delete historical data, or they cannot delete like 30 years old data, because imagine if you want to read your old email, what if they have like this recycle policy that they are going to delete all the information once in 10 years. So you cannot just read your old emails, right? So that is not possible. So they have to do something out of it. In the beginning period, machine learning algorithm was developed with the same use case, like predicting future, everything. But still, they didn't believe what it actually capable of. They just thought of the idea of predicting future is lame. So they didn't focus much of it. They concentrated more of storing and maintaining. But this time it came and they were like huge struggle going on. Only investment is going on and they are not getting any profit out of the data. So they just wanted to apply machine learning just to understand the customer and provide a better product. So that's when machine learning evolved. And you may think there's a word which is called data science. So what it is actually. So when it comes to business, they wanted a name where it should not say what they are actually doing, because when you say machine learning, it completely says what it actually does, right? So machine learning, learning machine, so it is easily understandable. So they wanted a name where it should not say everything, and it should hide the back-end process, and also it should express something out of it. That's when data science, the name data science came. SDS. So generally data, it is of 4 different kinds of data we actually work with, and it is available everywhere. So these are the data which you can just see everywhere. Whatever the data that you can see or handle or comes to you to make models, it will rely on these 4 categories alone. So the first thing is numbers. The second data type will be your text. Third one is your image. Even video format will come under image data. And the last one, which will be your audio. So at last, everything will be converted into numeric. That's how machine can read. So these are the 4 different kinds of data that we can build a model using with. Next. So we do have data, but we should have certain techniques to understand it, right? So these are the 4 types of analysis that machine learning holds, and also whatever the analysis or techniques that we do, it relies on these 4 categories alone. So the first one will be your description analysis. In description, the name implies it describes what kind of data, what actually the column, the meaning, and what it's capable of. You can just visualize it. The other name would be exploratory data analysis. That's the description analytics that we do. And diagnostic, which says like if you take a history of your medical history data that you take, and they will just diagnose with certain patterns, understanding the patterns and identifying patterns and say what will happen. So that is the diagnostic thing. And they won't give, in this analysis, we cannot just give a solution out of it, but we can say these are the patterns. And predictive analytics, which will use these 2 data, one is description and diagnostic data, and which will help you to predict the future or forecast the future, like weather forecasting, everything. And prescriptive analytics, which will be comes under recommendation. You're recommending some solution out of it. It's not only identifying, but you're recommending certain or list of solutions towards your business problems. So that's how prescriptive analytics goes. So these are some examples we would say which only learning algorithms can solve. That is identifying pattern, generating pattern, recognizing anomalies, prediction, because it's all about historical data, and whatever it is happening behind, it can just gather those information and get a new one out of it, or you can make a new one out of it. Prediction at the end. That's only learning algorithm can do, because you cannot just go on with a rule-based engine. How many rules we can build for a single problem? It should have a lot of rules in it, and it will be like really heavyweight. Machine learning or learning algorithm, which can make those rules into simpler, and it will become lightweight. We'll be just having one model, and we can just go on with multiple patterns, and it goes on. So that's how it is, like only learning algorithm can solve these kind of problems. So machine learning, everything is set, and we know it is for the future and all, but what it actually does inside and from where it got the idea. So there is 2 techniques which it got actually the idea from. One is statistics and another one is probability. We'll see one by one. So why statistics? Statistics is to test whether the data is having a proper quality. Just have it as like a quality checker or something. because everything is data and machine learning. If you are having a perfect data in the sense, it's not something it should be like in a perfect shape or something. No, the perfect data which will help you to understand your model, and you will be getting a good prediction out of it. Of course, it will be like having outliers, underfitting, it fall under underfitting or something else, but still you have to rectify those things and bring back the actual data which a model can perform well. So statistics which will help you to do that manually, as well as you can use some other tools to do that. But to check the quality of the data, we are using statistics. Let's see how. So the data should fall under this normally distributed way. Normally distributed in the sense, when you calculate the area under curve, value should be equal to 1. That's how you do. So how it is actually fall under this bell-shaped curve in the sense, normally distributed in the sense, the data which is collected everywhere. It is not something you created. It is a common data which is available, depends on your use case, so that you can have a range which will be normally distributed towards it. You can find this using standard deviation, where you can just select those information by using variance, by comparing the variance between every label present. So you can just think about the data in the left hand side, where I took 4 columns and 10 rows. You see there will be like lot of negative values, NANs, even zeros present. With this data, we can just directly say, because we are seeing it, it's so small, and we can conclude it, this data is not like properly set. We need to arrange it. We need to form it in the right direction. But what if your data is like around 10 lakhs of records? Even Excel cannot process with it, like around 10 lakh records, we cannot load. So for that, we need certain conditions and formulas. And also the first step will be removing all those anomalies in here. For example, NA and zeros and all, which will reflect in big time in prediction. So you have to rectify those information. But how? That you can resolve using measure of central tendency, which is 3 M's that going to resolve the problem which we are having in front of us. One is replacing your null values using mean. Mean in the sense average. Let's take, we'll be having arithmetic mean. We have studied arithmetic mean, where we'll be just considering only the elements which is present, and leaving those not present, like zeros and all, will be left out. So that's how we'll calculate the rows, and with the number of rows, we'll be just summing up and dividing it with the number of rows which is actually present, leaving those negatives or zeros and null values in it. But here we will be considering the entire population of it, because if we take a column 0, there is only one NAN. So summing all the columns, all the rows in here, and you will be just neglecting the NAs. So total number of the rows will be, here is 9. The next set will be taking, there is like 2 NANs available. Will you be considering number of rows is 2, and here it will be number of, and here we have zeros and all. So neglecting all these 0 and NANs, NAN will give you the total number of rows is 6. So if you can see, there is a mismatch in rows, and you cannot just have the population reduced. And normally in arithmetic mean, there will be like list of numbers that you want to calculate the average for it. But here it is considered as list of people, or it may be some information which related to the actual population. You cannot just reduce a population. For example, we are considering sampling to handle huge data. We'll be just taking out only the most out of it. let's take, we do have in a class of, 1,000. Let's say let's consider it's a huge set of data. But what if we are taking only, like 500 out of it? Then it is small, right? So our hypothesis, or the question that we need to predict is the set of pass percentage in next year. How much the pass percentage will be fall under next year, considering the population of 1,000 students. So we cannot just consider only the first benchers. So it will be like, or the toppers, it will be like only 100%. We cannot just conclude it with 100%. Or if you are considering only the middle benchers, I mean the average students or the below average students, the result will be 0 or even 50%. So we cannot just consider only this set of, we have to take out maximum out of it. For that, we will be using random sampling and all. We can just pull some information out of it and we can just go on with it. So this is how the sampling will be done. Even in sampling, after selecting sampling, you cannot reduce any of the rows to replace NANs, because it will affect in your population and that will cause some backdrops in your prediction. So that's how the mean will be replaced, and median is another way will be replacing, and mostly people will prefer to replace NANs with mean, because anyway we're going to arrange that in ascending or descending order and we'll be taking only the middle value of it. If it is like even number, will be just, even number of rows, will be taking out those two rows in the middle and taking average of these two rows will be set. NANs and zeros and all will fall under, since it's an ascending order, we can just fall under on the top of it. And next thing is replacing the NANs with mod. Mod is majority of value. If some numbers or some values is repeating multiple times, we'll be taking that value and replacing it with. So these two methods are most efficient than replacing it with mean. So that's how statistics actually helps to understand your data and make it in a quality way. The next thing is probability. How probability actually will be the key feature in building a machine learning algorithms. So this is the basic idea that the idea of machine learning actually evolved. For example, let's take an example of tossing a coin. The same example that we have studied n number of times, but we never understood why. So a single coin is tossed, and what is the probability of getting a head? So when you toss a coin, you'll be getting head and tail. So the probability will be 1/2, which is 0.5. So this one will be your prediction. What is the probability of getting a head? And this will be your number of samples, and this is your event, and this is your history of event occurred. So we do have number of occurrence and an event of occurrence and total number of sample. With that we can predict the future and what will be the outcome. So this is how the idea actually generated, and we are using it in a huge space. So this is a common thing that everyone will be having. What is the difference between machine learning and artificial intelligence? Let's start with machine learning itself. So machine learning is about making a machine to learn by itself, feeding so much of data and learning by itself. But what if I say even in machine learning, it can handle only few set of data? Few in the sense I'm saying like some 10 lakhs combination, we can handle that. And even it fails when you feed more amount of data. At one point, it will fail to react the way you want. That time we had deep learning concept slowly updated from machine learning, so which is totally evolved from machine learning. just to handle large amount of data. So deep learning, which will be the example algorithms it is having is neural networks, convolutional neural networks to handle large corpus. For example, image data. There will be like huge number of numbers in it when you convert that into a numeric format. So that kind of data can be handled only using neural networks, and I mean neural networks in the sense the form of deep learning, which falls under machine learning again. But what and where actually artificial intelligence relies on?
So, artificial intelligence.
It's not about learning, it's all about feeding the data, yes, but what if a machine start thinks for the possible solutions that you want? Of course, it is about data. Yes, you're going to feed a set of data that you want to have it with. But how much? The data is about the real-time data that you're going to feed for artificial intelligence. So it is going to be huge. But what is the difference in artificial intelligence? But what is the difference in artificial intelligence compared to ML and DL? The model built in artificial intelligence will be ensemble models, which is multiple algorithms combined together and trained together for possible outcomes. So we cannot just say there will be like only one outcome, that is yes or no, or even identifying a flower based on the petals. No. We cannot just judge what the outcome it is. Based on the use case, the outcome will be possible solutions. That is what the intelligence is. So that's how it differs, and to deal with huge number of data which is completely related to real time. So that's the difference between ML and artificial intelligence. So meet Sophia the robot, the actual example of artificial intelligence. So this is the first robot which actually referred by gender, she, and she holds a citizenship, and even she can vote, I think, in future, but we don't know. And she holds credit card also. But if you notice, she traveled over 50 countries. We may think why they are like taking a robot for 50 countries, or because taking a robot, it costs more. They need to get a power supply, everything, internet connection, everything they need to provide for it. It's not just traveling, and it will be like huge weights also, so they need some vehicle or anything. But why someone can spend so much money on a robot to travel, to show? It's not for showcasing or show off kind of thing. They are actually training her with real-time data, because it should resemble a human. It should react and behave like a human. They cannot just feed those information and sitting in one room downloading a data from internet. Internet can feed a number of data for a human, like how human can behave, how human can react, but they cannot just give the real-time data. So she have traveled over 50 countries just to understand the culture, behavior, facial expression, and some of words which newly generated, which cannot be found in dictionaries. So these kind of information they are trying to feed into Sophia so that she can behave. She is not expected to behave like every human. She should identify her own personality. So that's the ultimate goal of this project, an actual example of an AI. So let's see what actually the mission, how machine learning and how it actually learns. So when you take data, it is about points, and you're going to plot it in a 2D dimension. So this will be your input and this will be your output. So when you do that, you should get a straight line in the sense that's the most objective thing, most important thing in machine learning, that is finding your best fit. This best fit line going to be your prediction line, and it is constant. It's a line, so we are having a line equation which is mx plus c. It should give y. So m will be your coefficient and c will be your bias. Bias will help to adjust to a best fit by finding out the error and rectifying it with the help of coefficient, and will be getting back your y value. Let's say you want to predict 1, and mx plus c, which gave you 0.75. So the error will be 1 minus 0.75 equal to 0.25. This is your error, and it should rectify it. So this is how the learning actually does for every row in it. So there will be like columns like this, x1, x2, x3 and y. With the combination of all these things, we are going to predict what is y it is. So that's how the learning will happen in every row, and there will be like lot of layers and loss function which will be there, which we can see in future. But this is as a basic, we should understand how machine learning exactly learns from it. So this is it. So we call this as an independent variable and this one as dependent variable. Why it is independent in the sense, even if you remove any of this column, the other x1 and x3 will still have meaning in it. But when you do remove any of this column, y cannot be predicted. If the column is highly correlated towards your dependent value, when you remove that column, it will highly reflect and backdrop the operation of prediction. So that's how it is called as dependent variable. So types of machine learning, supervised learning, we know in a data it should have y label, that is dependent variable. It should have dependent variable. If the data, raw data or any data which doesn't have y label, then it is called unsupervised. That's when we go for clustering. And reinforcement learning, which is something different, what it actually does is understanding the pattern, where if you do not have a data for a particular hypothesis, it will generate those data by doing an experiment, by doing a trial and error method. It will able to understand the pattern and give you the data. That's how reinforcement learning comes, and it can be mostly used in R&D departments because they cannot be possibly having a data. They need to generate it. So for every combinations and trials, they'll be collecting those information, like surveys, like making a robot just to behave like a dog and training it. So that's how it is, reinforcement learning. So these are the libraries which will be mostly used in machine learning that will be seen. Whatever the examples that you try to use, you will be just using these kind of packages in Python. So Python is the mostly preferred languages for machine learning because there will be like lot of packages available just to build ML and a lot of resources which is available. So NumPy, which will be handling your structuring and other functions to handle your data, to store your data, and Pandas will be dealing with your structure of the data. It is completely table, right? So when you consider it as a table, that's when pandas, and it makes the operation so easily, and it will have a lot of arithmetic operations into it. You can directly calculate, and you can just describe in summary. You can get a summary immediately using panda. So it makes it the complete process easier. And for exploratory data analysis and all, you can actually use pandas. It will help in big time. I'll talk about a MATLAB and will later go on with other types. MATLAB, which is for visualization, just to visualize what you actually do. Because sometimes we cannot just give a model, right? We can show the graph structure of it, how it actually performs in a graphical manner. That's when MATLAB came, and a lot of other visualizing tools also available for higher end. Yeah. And sklearn, Keras, PyTorch, TensorFlow, which everything for ML model building. You will be having not a pre-trained model. Trained model, you don't have to train it again. You can just directly feed in your application. That's not needed any of the operations actually, because it is already trained with certain amount of data, and it is published for a betterment of use cases. But here it will have algorithms where you can pull out algorithms and you can use it for your own data, like linear regression, logistic regression, neural networks, any kind of algorithms you can actually do it. For big data purposes, PyTorch and TensorFlow will be used mostly. Thank you so much for watching my video, and leave a comment if I missed out any of the concept here. I'll just take out that in next session. So thank you guys.